Hi guys, today you guys are going to be working on a worksheet called Problem Solving with Linear Functions. Okay? Linear functions can be applied to many real-world problem situations to analyze the situation and to make predictions. Okay? I'm going to go through problem number 1 with you, and you'll be responsible for problem number 2, problem number 3, and problem number 4. Okay? So problem number 1. The A shift at Citco must drain an oil vat. 40 seconds after the plug has been released, there are 13 gallons remaining in the vat. After 1 minute, 10 gallons remain in the vat. Assume the number of gallons varies linearly with time. Okay? Now, we've talked before about the fact when it says something varies linearly with something else. This is telling you, this sentence right here, or this part of the sentence right here is telling you what variable is x and what variable is y. Okay? So let's make sure you understand that. If something varies linearly with something else, then the y always varies linearly with x. Okay? So in this particular problem, gallons is going to be my y variable and time is going to be my x variable. So when A asks, identify what is represented by the independent and dependent variables, hopefully you'll realize that the independent variable is the x variable. I'm going to put that right out here. It's the value represented by x, and that value is time. Okay? Now, also on this question, the dependent variable, which is the y, is gallons. Okay? Now, something really important in this particular situation, especially with something like time or a length or something like that, is that you specify how you're going to deal with that. Are we going to deal with time in minutes? Are we going to deal with it in seconds? Are we going to deal with it in hours? We need to specify that. Beside the general word, we need to be a little bit more specific so that when we do go fill in our information over here, everything is in the same measurement. Okay? So how are we going to measure time? Well, here we have 40 seconds, and here we have 1 minute. So of those two, the easiest one to convert one into the other at this point is time is probably talk about seconds, because 1 minute is just 60 seconds. Okay? So let's talk about time in seconds. Okay? So it asks us in B to fill out the table at the right. So an x value and a y value. Well, we've already decided that our x value is time. So we see several different time values in here, 2 at least. Okay? And I guess really all I see is 2, so hopefully 2 at most. Okay? So a time, the first time that we see is 40 seconds. In 40 seconds after the plug has been released, there are 13 gallons remaining in the vat. So hopefully you'll see that 40 seconds goes with 13 gallons. And it might be even a good idea to give yourselves a little abbreviation over here to remember which one is which. Okay? Seconds and gallons. The next value that we see up here in the problem is after 1 minute, 10 gallons remain. Okay? Now, I talked a minute ago about we can't just put 1 here because we're dealing with seconds. So instead of 1, because it says 1 minute, we want to put 60 because we're dealing in seconds. And 60 seconds deals with, is related to 10 gallons. Okay? Now, we're assuming this is a linear function. All right? So when we place the data in the scatter plot, C says place the data in the scatter plot and label each axis. Well, again, twice now we've already decided that our x value is time. So down here on the scatter plot we're going to put time, but again we're going to specify that we're talking about seconds. Okay? And our y value is going to be gallons. Okay? So we have only 2 points to place on the scatter plot. Is that enough? Is there a set number of points that you have to have in order to make a line? Well, hopefully by now you realize the answer to that is yes, and the answer is at least 2. You need at least 2 points to make a line. Okay? So when I go to plot these 2 points, when x is 40, y is 13, so that's going to be about there. And when x is 60, y is 10. So that's going to be about there. Okay? Now I need to connect these points. Oh, wait, can I? It says, first of all, I did C, right? C, would the data be discrete or continuous? Well, there's not an easy answer for this, because normally I say look for the equation. If there's an equation, it's continuous. If it's just points, it's discrete. But this is just points. That doesn't automatically make it discrete. This is one of those type of problems we actually have to think about what's going on. Okay? Can you have partial of your x value? Can you have partial time? Even though we're at seconds, can we go smaller? Can we have a half a second or a fourth a second or even smaller than that? And hopefully you realize the answer is yes, you can. Okay? Can you have a partial gallon? Can you only carry around gallons of fuel, or can you carry around 2.5 or 8 1/4 or something like that? And once again, I hope you realize that you can. Because you can have partial time and you can have partial gallons of fuel, I hope that you realize that this data is continuous. And because it's continuous, we can connect these 2 points. Let's see, sorry. Okay. So, is the functioning increasing or decreasing? Remember, we always talk about going from left to right. As we move from left to right, you can see that this function is decreasing. Okay? We're going to come back to this question later when we get to some more transformation questions and things like that. So I'm not worried about you doing this tonight for homework. Okay? Like right here, F on number 2, please don't worry about doing. Okay? So if we come down here to G, G says what equation results from using the linear regression on the data with a calculator? Okay? So I'm going to turn my calculator on. I need to create a new document. So I'm going to go Home, New Document, number 1. I'm going to start with a list and spreadsheet. Because even though I don't have a lot of points, I do have some, and I want to have both of those in there. Okay? So I have the point 40, or the x value 40 and the x value 60. And I also have the y value 13 and the y value 10. Okay? Now to help me out here in just a second, I'm going to go and name these. And remember, I have to move all the way up to the top. This is going to be seconds, S-E-C. And this one is going to be gallons. Okay? Now remember what we need to do next. Does anybody remember? I know you can answer me. I was just trying to make you think about it. Okay? We need to press Control Doc, because Control Doc will add a new page to this document, and the kind of page that we need is a data and statistics page, so number 5. I only have 2 points. Remember, yours may look different than mine. Okay, it may look different than mine. These points may be in different places on the page, and that's fine, because what I need to do is move my cursor around, move it here to the bottom of the screen so I can add my variable. And the label that goes on the bottom of my graph on my calculator is the same label that goes on the bottom of my graph, the x-axis in my graph on my paper, which is seconds. So when I move it to seconds, it moves these 2 down here, okay, to the axis. And then I'm going to go over here to the y-axis and add my other variable, which in this case is gallons. Okay, now that has created my scatter plot. Again, it's only 2 points, so there's one here and one here. So do you remember how to add the line of regression, the linear regression? Hopefully you remember that it's Menu, Analyze, right arrow for Analyze, and then go down to Regression. Whoops. We are trying to find a linear regression. Oh, dang. We are trying to find a linear regression, so we want to have mx plus b, so that's number 1. And when we do that, it puts it onto my graph. Okay? So hopefully you can see that our equation, our regression that we have here is y equals negative 0.15x plus 19. Okay? Negative 0.15x plus 19. Now it says graph it on the scatter plot. Well, we've already taken care of that. Okay? So H. Find the y-intercept. Well, yesterday we worked a little bit on y-intercept on that page of speeding through the lines. Okay? So to find the y-intercept, we're going to let x equal 0. Okay? Now if it's in slope-intercept form, hopefully you remember that y-intercept is just right there. So my y-intercept is going to be 0, 19. Okay? Now what does that mean in the real world? It's a starting point, right? Our y-intercept is always our starting point, so what did we start with? Well, we started with 19. 19 what? What's the label on our y-axis? So we started with 19 gallons. Okay? Any questions? I know you can't ask me. I'm sorry. I'm just trying to make you think. Now, what's the x-intercept? Remember, like I said a second ago, to find the y-intercept, you let x equal 0. To find the x-intercept, you will let y equal 0. So if we let y equal 0, I'm going to write 0 equals negative 0.15x plus 19. So to solve for x, I need to subtract 19 from both sides. I get negative 19 equals negative 0.15x, and I divide both sides by negative 0.15. Okay? So when I divide both sides by negative 1.5, what I get is x equals, I don't really know what that is in my head, so let's go over here to a quick calculator page. I just pressed that little calculator thing right there, a quick calculator page. That's like the scratch pad, remember? So we have negative 0.15, oh sorry, delete. I have negative 19, oh not minus, yes, 19, why is it doing that? I'm sorry guys. Oh, because I keep pressing minus, that's why. Okay, first of all, I know that a negative divided by negative is going to be a positive number, yes? So I can just divide 19 divided by 0.15. Hopefully you understand that, yes? If not, we'll talk about it tomorrow or after school today. Okay? So 126.667. So 126.667 is what I get with my calculator. Okay? Well, that's what I get for my x value, so my actual x-intercept, remember, is a point, so I have to write it as such, is 126 point, do you guys mind if I round it here? 126.7, comma, 0. That's my x-intercept. What does my x-intercept mean in the real world? Well, it's here, right? When it's where the line crosses the x-axis. So that means that's the time. So what do you think? When the gallons is 0, the time is 126.7. So hopefully you realize that the tank will empty in 126.7 seconds. The tank will be empty in 126.7 seconds. Okay? Any questions? By the way, here's that negative sign I was looking for just a second ago. I could do the negative 19 divided by negative point. Oh, except I did. When I press enter, it still tells me the exact same thing. Okay? All right. So, last question on here. Explain the slope in terms of its units. Before we can explain the slope in terms of its units, I have to make sure I know what the units are. Okay? So remember, slope is rise over run. What's the units of my rise? What's the units of my y-axis? Gallons. What's the unit of my x-axis? Seconds. Okay? So the way we say this, we don't just say gallons divided by seconds. What are we used to saying? We're used to saying gallons per second. Oops. O-N-D. Okay? Well, what is our slope again? Negative 0.15. Negative 0.15 gallons per second. So what does that mean? In the context of the problem, in the context of this problem, it means that the tank is emptying at a rate of negative 0.15 gallons per second. Okay? The tank The tank is emptying at a rate of negative 0.15 gallons per second. Now, some of you might be saying, oh wait, don't we sometimes call slope a rate? And yeah, this is one of the reasons why. It's the rate of change that's happening in the tank. Okay? So, I did number 1 for you. You're going to do 2, 3, and 4 before you come tomorrow. Okay? Please remember, and maybe not remember, but please know that we do have a test tomorrow on Thursday. So please understand that we have a study session after school today. I will be back. Okay? Study session after school today. We will have one before school tomorrow. Please look at the study notes up on the board. I will have them on my blog. If they're not there now, they will be very shortly. You can go look at my blog and get the study notes. And I hope you have a really great day. I'll see you after school for this study session, or maybe I'll see you before school tomorrow for the study session. Okay? Have a great day.